Hello, my dears. We're going to solve question 20 from the Test of Mathematics University Admission 2023 exam. It's a very nice question. I'm going to explain it to you carefully, step by step. Now, they've given us the graph of the function. X equals, it has its maximum value at 1. That's what the function says. And at x equals -1. It says the function has its minimum value there. It asks us to find the difference between the maximum and minimum values of this function. Now, to find the maximum and minimum values of a given function, we'll take its derivative. We'll set it equal to 0. We'll make a sign chart. And from there, we'll find their locations. Before that, let's write down a few things here. This is our fx function. There is a value where this function equals 0 here. I don't know if we'll use it or not, but f at 0 is equal to 0. When we plug in 1, we get 2. Therefore, f at 1 is equal to 2. And since this is the maximum value of the function, f, the derivative at 1 is 0. Here, since the function passes through -1 at -2, f at -1 is equal to -2. And since this is its minimum value, that means derivative at -1. Now we will proceed. Since we want to find the difference between its maximum and minimum values, we will take its derivative and set it equal to 0. We will take its derivative and set it equal to 0. Now, let's take its derivative. 2f of x times f prime of x minus f prime of x equals 0. From here, f. Let's factor out f prime of x. 2f of x minus 1 equals 0. Now, for this equation to be 0, either this part must be 0 or that part must be 0. The derivative, we will examine the case where f prime of x is 0 and the case where this part is 0. And we will create a sign chart. Everything we see here, that is, all of this part. Let's assume I wrote it here. Where is our derivative? Where is it equal to 0? Our derivative is at x equals. At 1, the derivative is 0. This is just one example, and at x equals, we can see at -1, our derivative. That is here as well. In our sign chart, at -1 and at 1, our derivative is 0. When does this green part become equal to 0? When 2f of x minus 1 equals 0. When fx equals 1/2, fx equals 1/2. When we move to the right from 1/2 on the y-axis, how many times do we intersect the function? How many times do we intersect it? I'll try to show it like this. If it doesn't touch there, I'll be able to show it. Yes. For example, let's say this point here. So let this be 1/2 on the y-axis. There is a point k here where the function takes the value 1/2. And yes, let there also be a point p here where the function takes the value 1/2. There is a k value on the left side of 1, that is between 1 and -1. There is a k value here. There is a root here. And on the right side of 1, there is 1 like this. There is a p value. There is also a root here. These two roots here came from the green one. And these two roots here came from the yellow one, that is from f. It came from fx. Now, what's important is to decide carefully whether the sign we start with right here, that is, whether what we write here is positive or negative. That's the point. Now, x equals, is the derivative positive or negative to the right of p? X equals, to the right of p, right here, our function is decreasing, so the derivative is negative. Let's keep in mind that the derivative is negative. So, to the right of p, the function takes values less than 1/2. If this were 1/2, then 2 times 1/2 minus 1 would be 0. But if our function takes values less than 1/2, then we should enter 1/2 instead of 1/2. Entering values less than 2 will make it negative. So this also turned out negative. Multiplying negative by negative made it positive here. We changed the sign at the root, minus, plus minus plus. Now increasing, decreasing, increasing, decreasing, increasing. The graph looks roughly like this. It asks for the difference between the maximum and minimum values. 2. There's a local max and 2 local mins. But while I was wondering which max and which min range it was asking about, my guess is that the values in this one and this one will be the same. The values in this one and this one will also turn out to be the same. So whether we solve it by taking this max or that max, and for the minimums as well, whether we take this one or that one, the result will be the same. Now, I think we should focus on this one and this one. It will reach its max value at x equals 1. So here we substitute 1 for x, and in f we calculate f at 1 squared minus f at 1. And we find the max. We find the maximum. When we substitute p, we find the minimum by calculating f at p squared minus f at p. F at 1, f at 1 was 2. Its square is 4, minus 2 gives 2. That's what we got. F at pp. When we substitute, we get 1 half. Its square is 1/4, minus f at p 1. Half. From 1/4 minus 1 half, we also get 1/4, right? No, it's not. We got minus 1/4. Now the difference between the max and min is being asked. The maximum value is 2. The minimum value is minus 1/4. They're asking for the difference between them. It's 9/4. In my opinion, it was really good. If you'd like me to solve other similar questions, you can share your thoughts with me. If you wish, you can also join our school community from the description section. All right then, see you next time. Goodbye for now.